Right, good afternoon, everybody. My presentation looks a little bit different, I'm afraid to say, but that's because changes in aviation safety is needed, and there's lots of different ways of changing this safety. I've been in the safety environment now for well over 30 years, and I still think that we've still got a long way to go. So, this is what has been put up in the UK, and really we've got to have a longer view on aviation because it was originally just fixed wings and helicopters, but as you know, with the great technology advantages of today, we have so many more available to us. Now, obviously, this picture is not quite there yet, which is why it's a research. It would be great if it was, but we're not quite there. However, what you don't necessarily realize is that we now have counter drones here that will actually capture drones themselves. We've got more structures in place that are going to affect the way that our operations are. In fact, a conversation I had earlier today has basically said, you know, that some of our rotor-winged crews are now providing information to eVTOL locations. This is not now going to be an interesting situation for both the legislation, but also thinking about the increased rates of what we need to monitor. And the reason I say about monitoring, well, we've got lots of lessons learned. How many of you have got cars today that will tell you that your system is ready? I mean, has anybody got a car today that will say system's ready? Mine does. I've got an electric car. It says I'm got system ready. Your helicopter today, how many conversations do you have to have before you actually take off? You know, there are more conversations you have to have. Why cannot your system be telling you what to do? So, I've talked about the landscape. However, the landscape is not changing as we would expect. It is changing slowly, and we still have a lot of old vehicles, yeah? A lot of these vehicles you'll have known from the 1960s, 70s, and 80s, and they're all changing roles, and they are expected to do more. Okay? So, one of the things that we've now talked about the challenge, is the part of the solution that enables this is the technology. Technology is what we do, and the main barrier to entry to this has been a bit of an interesting one to do with accuracy and reliability. So, this is how big these systems do. But what I was going to bring you back to is how people adopt the new structures and systems, whether it be an old vehicle or a new vehicle. So when the UK first introduced the legislation for the mandatory use of wearing seatbelts, unbelievably, there was a lot of opposition to the new law. Unfortunately, I'm old enough to remember it. And the opposition was sent to be just unbelievable. The education that needed to happen and the data provided for the vehicle's casualties was significantly reduced, means that seatbelts are now regarded as essential. So we've gone from something that we didn't expect, we didn't want, and to actually realizing that it's saving a lot of lives. Okay. So, I think I've written most of that there. Yes, I think I have. Okay. So, our barrier to entries then have been interestingly hard to deliver, especially within the health and usage monitoring systems. And the new systems that are now out there are taking into account the expandable nature of what these vehicles need to do. However, a lot of people say, well, monitoring doesn't actually give us any benefit. Well, I'm afraid it does. It's almost back to the seatbelt scenario. We've got so many different types of benefits, and I'm fortunate to work with an American company who've worked extensively with the US Army, so I'm going to give you some US Army facts. So, first one, the safety benefits. So, how many helicopters does the US Army have? Anybody know? No? 3,500 approximately. Yeah, so they've got 3,500 helicopters. So actually being able to giving you some proper diagnostics across a set of vehicles ranging across a range of OEMs has been able to give us some really interesting facts and some interesting benefits. So the US Army helicopters have avoided 4 Class A mishaps and avoid 11%, that were 40 material-related mishaps of all classes per year following the introduction of a more advanced HUMS. The maintenance benefits that can come about. Let's go over that one. So the maintenance benefits is about predictive maintenance now. We've talked about maintenance before, but predictive maintenance, the US Army qualified the reduction of 343,278 maintenance man-hours a year. Back in 2015, there was a fatigue of maintenance management. Of our maintainers. We've just done a recent fatigue structure for pilots. These new vehicles, this new environment we're moving into, our maintainers are now under so much stress, and we need to be able to enable them to do their job quickly and to make it accessible. By making this maintenance structure available to them, with the US team did 4,958 maintenance events. We optimize maintenance practices, resulting in over 50 airworthiness or equivalent STCs and 127 improved maintenance procedures. The other thing that works for us is our readiness. None of us want to have AOGs. We really want to make sure that our vehicles are available and available at all times. We found with the US Army that we experience one less mission abort per 100 flying hours. So 100 flying hours is not a lot in their vehicles, yeah? We managed to prevent that. We've also resulted in increased platform availability and readiness by 11.8%. So these are all exceptional pieces of information. Finally, we've looked at the maintenance benefits, we've looked at the readiness benefits, our operational and support cost benefits. These include useful life and efficiency, identification of certain problems and warranting ground and aircraft immediately, therefore preventing further damage and extension of life. Aircraft avionics and airframes have reduced overall vibrations on the aircraft, proven statistics with TBO extensions of 22 condition-based monitored parts and 5.8% reduction in maintenance test flights. This CBM and CBI projection gives the mean time between failure cost avoidance was in the region for the US Army of 25.7 million per year. It's a phenomenal set of data. A little bit an easy one for most people to understand is a recent example that we did with an OEM's vehicle, which failed. The part failed 100 hours after its first 100 hours of operation. The result of the warranty claim, in turn, gave the customer 200% return on investment. So there is lots of things that we can do and lots of structures we can build into just by looking after our vehicles and monitoring them. This is a particular incident. The operator was notified on July the 27th. In October the 17th, the main gearbox was removed from service following chip indicators. 100 flight hours after initial notification. The teardown analysis revealed the source of the metal generation was from the planetary bearing. Collateral damage led to replacement of parts throughout the main gearbox. Yeah, and this was identified 2 months earlier by our system. So, things that we do differently. So I work for a company called RMCI. We've done a lot of different structures, from advanced elliptical gear transmonitoring. This is an area that traditionally where we've ended up with fixed axis gear trains with synchronous time analysis calculations are relatively simple. However, as we move to the elliptical gear trains and non-fixed relative transmissions housings, the STAC ratios and planetary of the rotate of the planetary carriers instead of the transmissions housings, otherwise tack-divided data sections don't accurately correlate to gear rotations and desire gear mesh amplitudes average out. With this correct planetary gear ratios, the Army fleet did not process the epileptic monitoring capability through current health and usage monitorings on the AH-64s, the AH-64Ds, the OH-58Ds. And script files did not include sun or planetary synchronous time analysis. These sort of things need to be available to you if you're using your older vehicles, and you need to have systems and capabilities available to you if you're going to upgrade for those elliptical gear structures on those vehicles. Other things that the team's done has been CBM metric development, and also we've worked with the International Aerospace Industries Associations to affect and modernise national aerospace standards. We personally have got involved with over 670 of those NAS standards during the project. What I want you to conclude from this is that monitoring is available for not just the offshore. It's not just the police, the HEMS, it's for everybody. We are working in a more integrated environment. We need to be sure that our aircraft are available just as our cars today. Our cars today tell us we're ready. We need all of our vehicles to say the same, whether they are old or whether they are new. They still have a role and they still have a requirement for use today. I hope that's been of interest to you. If you've got any details that you want me to go through on the technical, please feel free to come and find me in the starter area of the show. And I'm going to finish there today. Thank you.